So between wildcards and loops, we now have some pretty effective tools in the shell to carry out powerful analyses that can scale to any number of files or subsets of files that we specify using clever wildcards. But what we want to look at now is another feature of the shell that really aids reproducibility. So if we were to perform some sort of analysis using a graphical interface, typically we'd click a bunch of buttons, and if we were very diligent, we'd write those down somewhere. But if we suddenly got a new load of data, in order to repeat that analysis, we'd have to go back and click all those buttons again, and hopefully we wrote everything down correctly and are able to reproduce the analysis. The shell makes this kind of process much easier, in particular via a feature called shell scripts. So let's look at creating a script now to see what it can do for us. So we're going to work now in the molecules directory. So to cd to that, we should want to do a cd ... molecules. So at its essence, a shell script is just a text file, like the ones we've seen earlier, that contains some commands that, just like those that we've been typing into the shell so far, which we can then ask the shell to execute the contents of that file and the commands that are contained within. So much like when we created a file before, we can use nano to create our script, and let's go ahead and create a script called middle.sh. So it's going to run nano middle.sh. As before, when nano runs, it takes over our terminal, and in here we're now just going to stick the command that we'd like to run. So let's run something where we go head -n15. Then we'll do this on octane.pdb for now, and then we will pipe that into tail -n5. So this is going to give us the 10th to 15th line of octane.pdb. Head will give us the first 15 lines, and then we'll get the last 5 of those at the end from tail. So to get out of nano, we press Ctrl X. We get prompted if we want to save the file. Press Y to confirm, and then return to confirm the name of the file. Now that we're back on our shell, we can execute the contents of the script file using the command bash. Well, using the command bash, followed by the name of the file. So you can see that we get some lines out. Judging by these numbers, we can see that they are indeed from the middle of the file, not from the beginning. And the output that we get is exactly as though we had typed those commands into the shell ourselves. So notice that we called this file middle.sh. It's still just a text file, and it's just a convention that is widely used that shell scripts should be finished. The name of shell scripts should finish in a .sh, just to sort of clearly indicate to people that it contains commands that can be executed using bash. So this is already fairly useful and allows us to keep a record of commands that we would run as part of analysis. But one of the more powerful aspects of shell scripts is the way that we can use them with command line arguments. So let's open up middle.sh again with nano. Nano middle.sh. And you can use the arrow keys to move around and backspace to remove octane.pdb. Then let's replace this with $1. We're also going to put some speech marks around this for reasons I'll explain in a minute. So as with the loop variable, $1 is a variable. In a script, $1 is a special variable that contains the value of the first command line argument that we provide when we run the script itself. So to demonstrate that, let's get back to our command line by hitting Control X, Y to confirm the save, and return to confirm the name of the file. If we now run bash middle.sh and provide one of the files in the current directory, so we can, for instance, provide octane.pdb, and you can see that now we get the same contents as when we specified octane within the file. Press up to recall the last command we ran, and instead let's give it propane.pdb. So now you can see we get a different set of lines which correspond to the contents of propane.pdb instead of octane.pdb. So we've gained the ability to run our shell script and apply the commands within it to whichever file we happen to want to use at any given time. So you might be wondering about those speech marks that we placed around $1 inside the script. So that's a good sort of practice that is worth adopting when you're writing shell scripts. That helps to protect against any instances where you have spaces within a file name that is passed as an argument to the script. As we've discussed before, the command line uses spaces to denote the different components of commands that are provided. So if your file name also provides spaces, then that can cause confusion when the command comes to execute head. It will try and run head on two separate files rather than on one file containing space. So adding double quotes around the $1 in that case helps to protect the variable and will allow you to use file names that include spaces. So we can further customize our script to include different additional command line arguments. So let's reopen the script with Nano. Then let's replace here the 15 with $2 inside of speech marks, and finally the 5 at the end there with $3 inside of speech marks. Control X to exit, Y to confirm, return to confirm the file name. So now our script expects 3 arguments. So if we then execute it, let's run bash middle.sh. Let's work with octane.pdb, and let's repeat the values that were there before. Let's use 15 and 5. So once again, we get the same output here as we did when 15 and 5 were contained within the script. But we now have the option to change these values to adjust the number of lines and which lines we get from the middle of each file. So, for instance, press up to access our last command, and let's change 5 to 3. So we should only get 3 output lines. We should get the last 3 that we got before, so we should get 11, 12, lines containing 11, 12, and 13 here. So we can also customize the actual work done by our script in exactly the same way by using these command line arguments. There's another bit of good practice that is worth getting into when you start writing shell scripts, and that is including comments to help in understanding what they are doing. So let's reopen middle.sh with Nano. Oh, apologies, I mistyped the file name there, so you can see I've typed .shh. So I'm just going to quit without saving here by pressing Ctrl X. Because I didn't make any changes in that buffer, Nano didn't ask if I wanted to save them, and I'll just press up to recall the last command and delete that extra H off of the end. So Nano middle.sh. We can then insert some extra lines at the beginning. And we can include comments in our script by using the hash character. So any line or anything that comes after a hash in a shell script is considered a comment and will not be executed by the bash when we run the script. So in this case, we're going to use the comments to provide some context that explains what our command is going to be doing. So let's say select lines from the middle of a file. So the reason we do this is that is to save people time when they come back to look at our analysis. Quite often those people are ourselves 6 months down the line when we need to revisit an old analysis. It's really helpful if we are able to have provided some hints when we wrote the code and we fully understood what it was doing. It really helps us to jot down a few notes now that will save us time later on. So let's include another line as well here. It's a good idea to also explain the usage of the command that you are going to, or for the script that you've written. So let's put an example that tells people how it should be used. So we want to run bash middle.sh. You then provide a file name. You then provide how many, which is the end line that you want to include from the middle of the file, and then the final argument is the number of lines from the file you want to include. As before, Ctrl X, Y, return, and we're back to the shell. There's one extra trick that's good to know when working with shell. So we've seen already how wildcards are really useful in the shell, and if we want to use wildcards with our own scripts, then there's something extra you need to know. So as an example, let's create a new script. Let's open a new file called sorted.sh with Nano. And then the command that we're going to include here is going to be wc-l. Inside quotation marks, we're going to put $@, and then we will pipe this into sort-n. I'll explain about the meaning of this special variable in a minute, but first we are going to write a comment that explains what this command does. All this does is it sorts files by their length, and you can use it by running bash sorted.sh followed by one or more file names. So the $@ symbol here is a special variable. When this script is executed, the $@ symbol expands to contain every command line argument that's provided. So if we provide only one, then $@ will contain only the value of that file name, but if we provide more than one, then $@ will be replaced with all of those. So that means that we can then get the full benefit of wildcards, and the power of the $@ is essentially allowing us to have variable number of command line arguments that we provide to our script. Let's just test that out and press Control X to exit, Y to save the buffer, return to confirm the file name. And then let's try this out. Bash sorted.sh as with middle.sh, and then let's use star.pdb to sort the file lengths in the current directory. And indeed, you can see we get exactly what we want, but equally, if we were to just provide two file names with bash sorted.sh, with methane.pdb and ethane.pdb, we can equally work with just two file names, one file name, or as many as we like.